مساء النور دكتور.
هلا الله يسعدكم. شايفين يا صبايا؟
شايفين.
طيب اليوم رايحين نبلش عن سابونينز جلايكوسايد. سابونين جلايكوسايد our saponins. By definition, we are going to see their biosynthesis. Previously, we mentioned that that the synthesis of our what we call it mevalonate pathway. We mentioned the diterpenes, whether we talked, remember, about glycosides, about vitamin K, vitamin E, in addition also silipocide. So when we talk about our saponins, these are terpenoids. So they are following the terpene biosynthesis or the mevalonate. Remember that what we remember starting previously when we talked about volatile oil, isopentyl pyrophosphate reacts with S-isomer dimethyl allyl to form our geranyl pyrophosphate. Geranyl pyrophosphate, again, for those asking questions, is the important or the base or the building block of all of our monoterpenoids because consisting of our two isobutyryl unit head to tail. Then we went to the what we call them ciscoterpenes. Ciscoterpenes from mevalonate also having 15 carbon atoms, 3 isobutyryl unit in the same fashion, head to tail. After that, we remember that adding another isopentyl pyrophosphate to farnesyl pyrophosphate, we are going to obtain the diterpene. We call it geranyl pyrophosphate. نرجع المحاضرة السابقة عن البيروفيت أو also here in generally we have again geranyl pyrophosphate. Plant for somehow they do not really go other by adding another isobutyryl unit. So here what I want to say that our saponins, whether we have triterpene saponins or steroid saponin, they are arising from the synthesis of two isobutyryl molecules. Two farnesyl molecules. Here we have our farnesyl pyrophosphate that here head tail, 15 carbon atoms, and another one here that we have our farnesyl pyrophosphate again, 3 isobutyryl unit, and these are reacts to each other and forming our squalene. So squalene is a triterpene. Squalene is a triterpene consisting of two farnesyl molecules attached to each other via tail to tail. Here we have here head, we have here tail, we have here head, we have here tail, we have here head, we have tail, we have here head, tail, head, tail. So tail to tail. If we look to our triterpenes, we can see that this is the farnesyl pyrophosphate, two molecules. They join to each other via, here we had that head, here we have the tail, and here we have the head, and here we have the tail. So we have the tail, here tail to tail. So again, squalene, like we mentioned before, squalene is considered the building block أو زي ما حكينا هي قطعة القماش المشتركة بين كل النباتات وكل نبتة تأخذ السكوالين. Then from squalene as building block is going to biosynthesize our triterpenes like ambergin, for example, is a typical triterpene. What do you mean by triterpene? From what we mentioned, the name mono 10, di 20, 30 is a triterpene. So 30, sorry, triterpenes having 30 carbon atoms biosynthesized via mevalonate pathway via conjunction tail to tail, tail to tail of farnesyl pyrophosphate. So what I want to say, they are not going to 20 بعدين على 25 بعدين بيضيفوا 35 لا بياخذوا 15 وال 15 نضافوا باثنين بصيروا 30. For this reason we mentioned previously that Cystiterpene, they are really not common. 25 carbon atoms are not common in the plant. They are there and they don't have that much effect, that much activity. And this here we can see that again the biosynthesis of all of our terpenoids arising from the building block of the building block of our the building block of our squalene. Again, squalene is arising from the reaction between two farnesyl molecules tail to form our squalene and triterpene. Triterpene and steroid also biosynthesizing from what we see from the same pathway, Here we have to know that we have the same biosynthetic pathway, we have the same building block of our compound, steroid and triterpene. When we talk about saponins, in fact, we have two classes. One class we call them triterpene saponins, and the other we call them trisaponins, steroidal saponins. So we have triterpene. Here also we have to focus in our compound lanesterol. Lanesterol is a terpenoid. We have carbon 1, carbon 2, carbon 3, carbon number 4, and here carbon number 14. Here we have number 14. What we see in lanesterol, here we should focus in lanesterol that the presence of two methyl group, and here one methyl group, so we have three methyl group. Somehow they don't know so far, scientists, why plant like to lose these particular three groups to form what we call it a steroid. So cholesterol is not a steroid, cholesterol is not a triterpene, it's a steroid. So from lanesterol by different steps, then we got a steroid which known as cholesterol. If we look to carbon number 4 here, we don't see any methyl group. If we look to carbon number 14 here, also we don't have any methyl group. So here, what would you say that the steroid, saponin steroid, or general steroid from the biosynthetic pathway are derived from the triterpenoid squalene. Squalene plant easily. For this reason, in plant particularly, we do not see any steroid has 28 or 29 carbon atoms, maximum 27. Why 27? Because plant losing these three methyl groups. If we see here that we have our compound, but as just looking at them here, we easily you can say that this is a triterpene, this is a triterpene, and this is a triterpene, and here lanesterol is a triterpene. If we go to this one also, this is again triterpene. So all of our compound here that we see them, all of them are triterpenes. If we look to our triterpenes here that we have our compound, as we mentioned here that we have the numbering system. In our numbering system, the most important all the time we should look at carbon number 4 and number 14. If we have two methyl groups attached and one methyl, we called it, we called it a Trited. So when talk about saponin are glycoside. Remember our glycoside again. These are sugar and non-sugar attached to each other via different bonds, as we are going to see. So here produce forming a circular frothing aqueous compound. If we go here for more compound of our properties, when we talk about saponin, in fact, is derived from the sapo, and the sapo in Latin means soap, sabun, soap-like. Why we called it here? Here, saponins generally they are amorphous colloidal. Amorphous colloidal glycoside means these are not crystallizable compounds, not crystallizable. So these are non-crystals, so they don't really have a sharp melting point, and they are amorphous. They found in higher plant. Again, these are secondary metabolites. Also have ability to form lasting foam when shaking an aqueous solution. this is this is most of the time is we do it as a test of the presence or absence of saponin. We take the plant from the plant, a small amount of plant, put it in test tube, add water, then shake it. If there is a ring of foam is formed in the test tube, this is a positive indication that we have saponin. If it's not here again, they are excellent emulsifying agent here, excellent emulsifying agent, and we know that modifying surface tension for this reason a lot with these soaps in cleaning, either cleaning our bodies, our faces, or clothes, or whatever. So why do we employ them? This is due to their surface tension, also to their emulsifying activity of our soaps. and formally قبل اختراع الصابون والمنظفات الجديدة كانوا بيستعملوا نبتة اسمها كولايا. Qualia, one of the most important plants containing our saponins and saponin glycoside. In addition, also saponins are colorless, but they are amorphous. They are and optical active. They form colloidal solution, as we mentioned, with water. They are also soluble in alcohol, dilute alcohol. Another thing also we can test. This is another test. We can determine the presence or the absence of our glycoside in the same test tube. We add to the solution of our saponin, we add the blood, only few drops of the blood. If its hemolysis occurred, this is a good indication that there is a saponin. So because saponin, they have hemolytic properties. Here in the red blood cells, this hemoglobin is liberated, and this is again another indication, very simple, easy test. We can determine it to determine whether or not having our saponin. Again, our drug is as we see, saponins are extremely toxic when injected into the bloodstream, and they are not harmful when taken orally. عادة الإنسان اللي بأخذها أو عن طريق الخطأ بيشرب حفنة وعليها صابون أو ما شابه ذلك، بتلاقي تلقائيا بصير عنده القياء، فبتلاقي بقيئها. المشكلة هون في what we call them cold blooded ذات الدم البارد، مثل الأسماك إذا أخذت مادة الصابونين تلاقي تؤدي إلى نفوق الأسماك جدا. برضو في المناطق اللي موجود فيها الكولية أو نباتات ثانية موجود فيها الصابونين، بنشروا على الساحل بتكون كمية دقيقة من نشارة النبتة على الساحل، فتلاقي بتركوها بالليل فوق الشباك، ثاني يوم بيجوا بيلاقوا كل شباكهم مملوءة بالأسماك. So what we hear here for warm-blooded like us, really we don't have any problems. Cold-blooded like fish is very toxic, extremely poisonous to this one. Also sapogenin, again we have to know to what we call it the glycon. here that we have our terpenoid as we see, and here also we can see if we look to this compound, lanesterol again is again, and here we have carbon number 4 and also carbon number 14. So we have the 3-methyl. Rightly, directly we say this is a triterpene. Meanwhile, for cholesterol, we don't have here any 2-methyl and the methyl 27. So right away, this is a steroid. This is also the official steroid numbering system, whether we talk about triterpene or also not a triterpene. Most important that we have carbon number 4, number 14 are the most important here. Here, what we have to know that our steroid are very important for our compound. And here again, that when we talk about steroidal glycoside or saponin general glycoside, that we can have or classify them into classes. The first class of saponin glycoside is known as a neutral saponin. Again, our subject, so saponin glycoside, we mentioned saponin glycoside could be a triterpene and could be a steroid. Now we know the difference. What do we mean by a triterpene? What a saponin? And also the saponin or the glycon, we have the glycon and the non-glycon of our drug. We are going to see what called sapogenin. So generally for our saponin glycoside, we can classify them in two classes. The first is known as neutral saponin. Neutral saponin, as we see here, our compound, our saponin here in front of us is a saponin. We look at it, we don't really have any functional group. It's a neutral. So steroid derivative, how is steroid? We look at carbon number 4 and carbon number 14 right here. The absence of the 3-methyl group, so right away is a steroid derivative. Also, another